Hello, this is Paul from First Attack. In this video, let's prove the Theorem 3.4.3, which is a property of a linear system, of a homogeneous linear system. See, and the homogeneous linear system is Ax equals 0, right? A is the coefficient matrix. Suppose the size of the matrix is m by n. Therefore, we should have m equations and n unknowns, right? So we can set up, and then the result says this system, the solution set of this linear system consists of all vectors in n space. Okay, the size of x should be n that are orthogonal to every row vector of A. Okay, so any solution is perpendicular to each row of the matrix A. Why? And we can prove this easily. Okay, so we can do this. Let me set up. Suppose matrix A. We use Aij to describe. Okay, so let me set up directly get the linear system. So the first should be A11, right? X1 plus A12 X2 plus A1n, right? N unknowns Xn equals 0. The first equation. And then the second equation, the 21 X1, the 22 X2, that goes to a 2n Xn, also 0. I ignore the middle equation. The last equation should be am, right? 1 X1 plus am 2 X2, and then goes on to am n Xn equals 0. You can see, and this should be the linear system. Okay, so now what is the first equation mean? Okay, so we can set up. Okay, so what is the first equation? See, the first equation, we only look at this part. The sum of product, right? Sum of product means dot product. Okay, so what the dot product? So x1, x2 to xn is the vector. Okay, so I will look at it. If I say A11, okay, A12, go to A1n, okay, is a vector. This exactly is the first row of matrix A, right? So let's say this is row 1. Okay. This exactly is the first row of matrix A. And then X. Okay, so you can say set up X. So of X1, X2, go to Xn. Okay, this is all the unknowns. That's the vector X. Okay, which is a solution of the linear system. And then that equation 1. Okay, see, if this is equation 1. So easily we see then equation 1 is just equivalent to dot product, right? R1 vector and the unknown vector equals what? Equals 0. Yeah, definitely. Okay, so this is the dot product. The definition for the dot product is the same for the second. Okay, right? So it's the same for the second. So the second equation should be the second row of A dot X, okay, equals 0. And then if we go on, see, and definitely we will have all of, let me get any equation should be any row of A dot X equals 0, and I start from 1 to the last row, which is m. That makes sense. Okay, so this is the linear system, exactly the same. And this is the R is the ith row of the matrix A. See, this is just the result. And this equation gives us X should be perpendicular to any row of A, right? Okay, so therefore, this exactly means what? It means X bar, the vector unknown should be perpendicular to Ri. Okay, so perpendicular. And any row from one to the last row. And that's the result of the theorem. So X is the solution. Solution should be perpendicular to any row of the coefficient matrix in the homogeneous linear system. That's all. Thank you.